Well, hello there again, friends. Today is 8/17/2022, and today is the Odin Project Vlog Day 142. And I am on part 2 of Project Recursion, and I have completed the merge sort. So I won't read through all this. I'm sure you guys already have, but I do encourage you to if you haven't. Um, on merge sort, there's several key things that you want to understand as far as how it works, and they kind of outline that through these videos for background viewing. So make sure you go ahead and check those out before you start the algorithm and start the logic, because otherwise it won't really make sense. They do a really good job, and I won't try in this video because I won't do justice, but especially the YouTube videos do a really good job of describing what it is we're trying to do here. And so I'm just going to kind of abbreviate over that and go right into the assignment. So here we are. We're going to build a function called merge sort that takes in an array and returns a sorted array using a recursive merge sort methodology. Tips. Think about what the base case is and what behavior is happening again and again, and can actually be delegated to someone else. Example, that same method. It may be helpful to check out the background videos again if you don't quite understand what should be going on. And I did do that. I actually watched all these at least once, some of them twice, to get a good grasp for the algorithm, because it's not the easiest thing to wrap your mind around. Conceptually, it's not too bad, but when trying to put code to code from paper to code or mind to code, it gets tough. Just keep at it. And then that ends the section. Sorry, my Tourette's is super active right now, as always. So anyway, we're gonna hit the code editor and show you what happens. So here's what I did. So I have a comma here. Assignment 2, merge sort algo, use recursion. So I have a constant ES6 merge sort function that takes in our array. So we're going to give it the parameter of the array, just like it said in the requirements, of any length. And I have two base case scenarios. So if the array.length is 0 or 1, I'm going to return invalid array supplied. If it's a 0, that just means that what it sounds like. That means that it's either put a number in there, or it wasn't or they put a letter in there, or it actually wasn't an array at all. And so we're going to tell them it's an invalid array and need to try again. If they give array equal to 1, meaning they only give one digit, we're going to just return that back out. That array item back out because there won't be anything to sort, so it'll be done. If it doesn't pass the base cases, this is the recursion portion here. So I have two constants, split left and right. So split takes on math.floor array.length divided by 2. So what it's going to do here is it's going to take the length of the array, divide it by 2 to get basically the halves, the two halves, as per the algorithm logic you have already learned about from previously. And then math.floor, if you remember, that basically returns the largest integer less than or equal to the given number. So basically it's going to compute this value, whatever it is, 3.5, 3, or whatever, and then floor is going to round it down. So if the answer was 3.5, it's going to round it down to 3. That sort of thing. If it's 5.05, it's going to round it to 5. If it's 5.95, it's going to round it to 5. If it's -5, it's going to round it to -6. So you get the point. And then constant left and right is the array.slices. If you remember, slicing is the method to return a shallow copy of a portion of an array into a new array object selected from start to end, and the original array is not modified. So what this does is gives left and right its own shallow copy of a portion of an array. So basically we're going to say array.slice, which is our input array, and we're going to start at index 0 and we're going to end at split, which is our math.floor calculation from here. So basically we're going to slice out that left-hand side of the array, and we're going to input it into the variable called left. Same for right, so we have right here, and we're going to array.slice, and instead of starting at 0, we're going to start at the split definition. So that will be whatever the math comes out to here for your have. So it's going to start at array item or array position, index position, whatever, say 3, and then we're going to end at array.length, which is just the end of the array. So we're going to go, then it'll be the right half. And then we're going to return a merge and merge sort. So I hope you understand the algorithm, how it works, because at least conceptually, because this is going to be hard to explain in words, and I don't have any graphs to show you for graphical representation, but so I'll do my best. So basically what's going to happen here is we're going to have merge sort left and merge sort right. So what's going to happen is going to come down here. It's going to think of it as like an accordion. So we're going to pull out the accordion. We're going to go from the greatest down to the smallest, and we're pulling the accordion out. And so every time we do a merge sort on left and merge sort on right, we're going to push it back into merge sort, and we're going to loop through, or not loop through, we're going to recursively circle through every single merge sort until left and right are resolved, and there's and base cases close it out. So just remember, that's the accordion coming out, and all the merge sorts are going to have be running through these left and right splits. So basically, we're just simply recursively splitting through and having each array and in each side. And so since merge sort is inside a merge, we aren't running merge yet. We haven't called merge because we're still running through merge sort because it's the innermost. As you know, the innermost parentheses is always ran first. So once that accordion mentality or thought picture is fully pulled out, then we're going to call merge on everything. And if you remember from the videos as well, now we're going to push everything. We're going to push the accordion back in. So everything is going to come back together as one single entity. So merge is going to be called, and it's going to take on merge sort left and right, but it's not just a single left and right. It's going to be the entire recursion of however many times that merge sort was ran. I really hope this makes sense, because if you didn't watch the videos up here in this section, the one I'm saying here probably isn't making a lick of sense. But anyway, so when the merge is called, so the merge sort is basically going to keep splitting this and creating left and right halves until it can't anymore. And then when that happens, merge is going to come into play here. And so when merge is called, it comes down here, and it takes on the left. It takes parameters of left and right, which we're supplying from the recursion. And so this is not recursion. So my merge, I have a merge function here. It is iterating with 3 while loops, and we'll get to that in a second. So what we're doing here in merge is we're going to combine both the left and the right array parameters together. So we're going to create a constant variable called result, which is an empty array, and we're going to create 2 variables called incoming left and incoming right, and they're going to equal 0 to zero out the values, and that we'll be using those for our iteration. So we're going to have a while iteration loop here. So basically, if incoming left, which starts out as 0, is less than the length of the left array, and incoming right, which is currently 0 in this example, is less than the length of the right array, we're going to go ahead and run through an if then else statement here. If the left side array with incoming left, which I'll just abbreviate that and say at index 0, is less than the right side array index 0, we're going to then push the result. We're going to push to the result array that we have defined up here, our empty array. Oops, sorry about that. We're going to push in the left, incoming left, position 0 in this example. We're going to push the left array item into result. So, and then we're going to increment incoming left plus plus will increment it by 1, and we're going to continue inside of this while loop, not recursively but iteratively. This is iteratively, iterate, whatever, you know what I mean. It's not recursion because this is a loop. This is a while loop, of part of a special for loop. So we are iterating through, and so if this isn't right or isn't true, meaning left is not smaller than the right side when you're comparing the value at position 0, we're going to push the right side into the result array and increment the incoming right value by 1. And then we're going to keep iteratively looping through that until that becomes until that while loop is satisfied. And then or becomes invalid. So basically at some point you're going to get an issue where either you're not going to get ands for both of these. You're going to have either this is going to be true, where you're going to have your incoming left is less than your length, or your incoming right or your current index value is less than your length of your right array. Then you'll come down here, and this is where we run cleanup to make sure that we ingest all the values that are present. So here's a while case for checking the left-hand side array. So if the iterated index value is less than the length of the left array, we're going to push that current value inside a result, and we're going to increment that incoming left array index value again. And same thing on the right, just opposite. So if the incoming right index value is less than the length, we're going to push the right value at that particular index position into a result, and we're going to increment the incoming right index value and do it again, and keep iterating through both that incoming left and incoming right until those are satisfied. And then we're going to return the result at the bottom, and that will spit out what you have here. So to see that in action, I have a console.log recursion merge sort algo, and then I call the merge sort inside of it, kind of like we did in the previous video. And then I put in some values in here inside of an array in jumbled up order on purpose. So I have 8, 5, 1, 9, 7, 15, 4, 2, and 0. And you can see the output result of that is in sorted and the correct order: 0, 1, 2, 4, 5, 7, 8, 9, 15. And we can also test this with, let's see, how am I doing on time? Doing good. So we can test this with one value to test the base case. So if I do Control S and save that, there you go. Spits 8 out because 8 is part of the base case up here. If you remember from earlier, we have a 1. We're just going to return the array. And so if I put nothing in here, we ought to get the error message. Yep. Invalid array supplied. Excuse me. So there's that. And any other version. So if I put an A in here, yeah, just put like, no, that's going to give me an error because that's a variable. But if we put an A string in here, this also should give us an, oh, okay. Well, I guess that that spit it out because it treated it as a string. I never tested that, so there you go. Fresh test. So it actually worked on that because it treated it as a string. And I think I'm going to get an error here if I use A because it's going to say undefined variable. Yep, it is not defined. So, so I guess there's a base case that wasn't used or wasn't tested. which is you could add that. I didn't add that till just now, just thought of it, but you could add a since it's processing it through, and that's not technically a number because this is a merge sort number array test algo, whatever you want to call it. You could put another base case in here saying, if array equals a string or whatever, or array.length triple equals, so it gets to strict equals, and you put empty quotes in there, so you could do return invalid array supplied or something like that, and that would cover it for strings. But you may want to evaluate a string letter perhaps, but it won't work in this algorithm because we're doing division and we're doing numbers, so maybe it does make sense to do that. So let's see if I added that real quick, if that would. I don't want to make this video overly long. Yeah, I won't do it. It's at 16 minutes, but you get the drift. You could add the base case in there, and it would work for that. So put it back to what I had, and that works great. So yeah, so I think I got everything. I don't think I skipped anything for explanation. So excuse me. That'll wrap it up for this project. Short and sweet here, and additional resources if you're interested. And we will be going into the next section after this. So thank you for coming along the journey today. Hope you learned a little bit, had some fun. Please like, share, and subscribe for more content. And let me know in the comments section how you guys rounded out this assignment for merge sort and what you thought of the project as a whole. So with all that said, till next time, see ya.